In this example, we're now going to look at a cylindrical geometry. It's a closed surface, so to again get our perspective in order in place here, the surface area we're looking at is the cylinder here. So I have the one top of the cylinder shown here, the area pi r squared. The bottom cap is not shown, that would be over here. And then what I call the shell is the curved portion. So this portion here, right, the curved portion, all in here, is the shell. Now, the n-hat vectors, as we said, are critical to calculating the flux, so let's talk about the n-hat vectors. Well, the two n-hats that go with the end caps are pretty straightforward. By convention, the n-hat vectors point outward from a closed surface, not inward. So that's why the n-hat goes out from the surface. We have an n-hat out from the bottom, the right side end cap. Now the n-hats for the shell, I just have two representative n-hats drawn in here, one towards the top and one towards the bottom, but really that shell is three-dimensional. It's curved, so we would have n-hats all around here, kind of like spokes on a bicycle wheel. And all of these n-hats will be perpendicular to this blue E vector that we have drawn in here, this E1 vector. So to finish our perspectives, the two electric fields we're given to consider start at the origin. So E1, we say, starts at the origin and moves to the right, is pointing to the right, positive 300 newtons per coulomb in the x-hat direction. And then the electric field E2, again, starts at the origin and moves to the left, same 300 newtons per coulomb in the negative x direction. Now we want to calculate the individual flux values and the total flux, the net flux that's in this problem. And you notice it says here outward flux right from the start because there is no inward flux. There's no electric fields that point in to this closed surface. So let's take a look at our flux calculation for each of these E dot n hat A's. So I have them drawn out explicitly here. So for our left cap, we have E2 dot n hat A, where the A is only the area of that left cap. Okay? The n hat goes in the negative x hat direction. The light blue E goes in the negative x-hat direction, so that's why we have cosine of 0 when they're drawn from a common origin, and then we have similar language and argument for the cosine of 0 degrees for the E1 and the n-hat on the right-hand side cap. So those give us cosines of zeros. Notice the shell will not contribute to our total flux calculation because the electric field itself, both the light blue and the dark blue, and I'll just address the dark blue one here, rides along the shell. No portion of E1 is going to go in the direction of n-hat or against the direction of n-hat. So because we get our cosine of 90 degrees between the n-hat, we can just let cosine itself dictate our answers. If we apply the mathematics correctly, we will always get the right answer. So the shell, it turns out, has no flux. So part B of our question is answered. No flux through the shell because the electric fields ride along the shell. Well, when we finish our mathematics and calculate the flux through those two end caps, those both add because they are outward flux. Notice cosine of 0 degrees and cosine of 0 degrees gives us two positives. Cosine of 0 is positive, 1 in both cases. So we get identical flux values, both positive, pointing outward for the electric field. So the flux is positive for both the right cap and for the left cap. And then we get our total flux, of course, is our positive 3. And the positive here means out. So now we're beginning to use the language like we used for energy, where we have energy out and energy in. So here we have our outward flux for our closed surface is what the positive means. If it was negative, then we would have a net inward flux. And again, no vector answer, right? No vector answer. I don't put it in here. Please do not put it in there for any flux calculation. So I'll zoom out, let you take a look at the whole page. These closed surface calculations will be critically important for us when talking about Gauss's law, so please make sure you ask questions if you have anything that is unclear about the explanation on this page.